What is up guys, this is Alan from FPV Creator and welcome to the first video of FPV Creator Academy. In this series of video, we'll be going through how to build, test, fly, and film with an FPV drone, all from scratch. So you might have zero experience on how to build an FPV drone, and that's totally okay because this video is made just for you. So in the next couple of videos, just simply follow our step-by-step instruction on how to build an FPV drone and you'll be ripping the sky in no time. Now keep in mind, right here, this entire series of videos is 100% free. So that means you don't need to worry about like watching on episode 3 and all of a sudden we ask you to pay something. No. This video series is 100% free. And why? Because we just want more people to start flying FPV without spending too much time crying about your burning fingers or your bleeding fingers. So anyways, I'm done promoting, let's get into it. So in this video, I'll be going over what FPV components do you need and what each individual of them do. So treat this video as like a kind of like a list or also an introduction of what you do have to buy in case you haven't bought them. Now keep in mind there are thousands of different components out there exist on the market, so even if your motor doesn't look like mine, that's totally fine. They work in a similar way. And I'll tell you when it's slightly different, so you might have to look up YouTube on yourself, but for the most part it's the same. Anyways, let's begin. So the first thing I want to talk about is the frame. This is a frame from iFlight. And iFlight is one of the company that has been really active recently in the FPV world. Let's open it. Yeah, might have some problem opening this. Okay, I got it. So this is a frame. And what a frame essentially does is that it's like a skeleton for your FPV drone. Everything you have that's flying goes onto the frame and it gets fixed onto the frame. So this way, your frame provides protections for the drone. It's also like a backbone of your drone. Now, different frame might look different. If yours look like this one, which has a really long fuselage that looks like a rectangle, or in other words, looks kind of like a coffin with 4 arms, this is probably a traditional freestyle drone, and this is the thing that you do with it. Now, if your frame looks like this with a little island in the middle, also with 4 arms, this is usually made for racing, and FPV racing looks kind of like this. At last, if your FPV frame kind of looks like this is what we call a dead cat. And dead cat is usually made for long range flying, which you fly kilometers and miles away, or it's for cinematic, because when you put a camera in the front, the propellers usually wouldn't obstruct the view. Anyways, so some frame like this, they're pretty complicated to assemble, like this one. So usually frames come with a user manual, and for example this one, it sure does, but I mean still look kind of complicated, not going to lie. But that's okay, I'll be going over how do you build this frame specifically, and even if you're using another frame, it's probably the same, because, okay, next, this is a motor, and let me open it real quick. This motor is made by T-Motor, which is a really awesome brand in FPV world that makes high-end motors. And what a motor does is that it turns the potential energy inside your battery into rotational kinetic energy. Okay, that might sound a little bit complicated, but trust me, it just spins. That's literally its only purpose. Now, this is a brushless outrunner motor, and usually a FPV drone uses one of those motors. And on a motor, there's usually 2 4-digit numbers. This one right here, 2306, represents the size of the motor, where 23 is the diameter of the stator or the rotor, and 06 is the height. Now, this number right here is really vague because it either means the diameter or the height of the stator, the rotor, or the motor itself. So, but different manufacturers have different definition for it. So all you need to know is that as long as it's something like 2306, 2304, 2305, 2207, 2205, 2206, or even 2407, you'll probably be fine. Because they're meant for FPV drones anyways. Right here, the smaller number right here, that usually comes with a kV. What kV means is voltage constant. And you can find a rotational speed of this motor by multiplying this number, or the voltage constant, with the input voltage. So for example, this 2400 kV motor, if you times it by the input voltage, which is usually 14.8, then you get this much RPM at max speed. Now keep in mind, this calculated number is only going to give you a rough estimate of the speed, since you have different propellers and you have different flying conditions. So the actual rotational speed may be varying. Now next up, we're going to talk about what an ESC is. And ESC stands for Electronic Speed Controller. It might sound complicated too, but trust me, it's just a motor driver. So you connect your motors right here, and then you also connect this side to a flight controller, and the flight controller sends signal to the ESC, and the ESC responds to that signal by changing the motor speed. But besides that, it's just a motor driver. Now let's talk about flight controller. The flight controller is basically the brain of your FPV drone. It is, you can understand it as a CPU. As mentioned earlier, you plug in your ESC into this module, where this thing tells the ESC what to do. You also plug in the receiver into this module, and basically this module listens to your receiver and it tells the drone what to do. Now usually in a flight controller there are two sensors, the accelerometer and the gyroscope. And together these two sensors help your drone to hover in an upright position. And even if your drone is not in an upright position, it will always know which angle you're supposed to be at and lock your drone at that specific angle. You might also have other sensors, like a sonar sensor or a GPS. You also plug into this. But that's pretty complicated, so we'll leave that in future videos. This right here is a battery. And, I mean, you probably already know what a battery does. It gives the drone power. Yeah, I don't think I really need to explain much about this. This thing right here is called a receiver. And this receiver I'm using is called a TBS Crossfire Nano receiver. It is one of the best receiver on the market because it supports extremely long range and is extremely reliable. So now receiver is extremely tiny. Now as I mentioned earlier, you plug this receiver into a flight controller. What a receiver does is that it receives the signal from your transmitter, and your transmitter essentially tells the receiver what the drone input should be, and the receiver tells the flight controller how should the drone fly, and the flight controller actuates this signal into real flight. This thing right here is the Air Unit for the video transmission system. It has two parts to it. There's the camera, and there's the video transmitter. The camera captures what it sees, which is basically what camera's supposed to do, and sends its signal to the video transmitter, and the video transmitter transmits the signal to your FPV goggle. And that's how you see things inside your goggle of what your drone is currently seeing. Now also don't forget, there's also two things that attach to this, which is called the video transmitter antenna, and it's stuck in this box. Those two are the video transmitter antennas. They basically amplify the signal inside this video transmitter. I mean, you probably know what's antenna already. Also, I wouldn't forget about these three things. I'm gonna go through them one by one. This is called a goggle. This is a controller. And this is a range booster, or an RF module, or a TBS Crossfire, whatever you want to call it. Let's go through them one by one. The goggle is what you put on your head. And then you can see what the drone sees as long as this thing is in your head or on your head. And whatever that transmitter thing I mentioned earlier, it sends signal to this thing so you can see it through your eyes. This is a controller. It has two joysticks and has switches and buttons that you can customize yourself. And this thing controls the drone. This thing right here is kind of like a range booster. It disables the internal module of your transmitter, and then uses an external module to transmit signal to your drone. Now, what's the difference? Well, this one is much more powerful than the ones inside your transmitter. Unless you're using a TBS Tango, which has built-in Crossfire modules. Now, these things, they snap to the back of your controller usually. As you can see, I already have one here. This one snaps directly to the back of your transmitter. And it acts like a range booster. Now, this one's optional, so it's not like you absolutely need it. But if you're gonna dedicate yourself a couple years or even months into FPV, or you wanna fly in really remote places, or chase cars, or you want extreme reliability, then definitely you need to get one of these. There are two types of goggles, the analog goggle and the digital goggle. There are a lot of difference between them, but generally, I'm gonna simplify them in this video. The digital goggle, what you see in a goggle, looks like this. It's a lot more clearer. I think the resolution go up to 720p or sometimes in the future even 1080p, and it goes up to 120 frames per second. This is better for freestyle pilot because it shows high quality, especially for cinematic pilot, because you want to see what the camera sees. And a digital camera on a drone is closer to whatever HD camera you put it on there compared to an analog camera. But this thing is so much more expensive too. The goggle itself is about $500 to $600, and it's only being produced by one single company, DJI. So that means you don't have any choice. It's just one company. And then for the video transmitter, it costs anywhere from $120 to even $200 sometimes. And there are only two companies that produce them, Cadex and DJI themselves, which don't really have much options, but they are pretty reliable. So every drone you build, you have about $120 to $200 spent just on the video system. And the one-time investment for the goggle is $500-ish. Whereas analog, you have a lot of choices. By the way, it's also older. The goggle can range anywhere from $200 to even $600 sometimes. But then the video system can get a lot cheaper. In fact, a good video system that's reliable usually would not cost more than $100. For example, you can spend $30 on a reliable FPV camera and a $50 on a reliable video transmitter, which in total $80 to $90. It's also known that analog goggles are much more reliable than digital ones because they're, well, older, except their quality is much worse. Now, one key difference between digital and analog is that digital, when it loses signal, it instantly cut out. But the analog, the noise gets more and more as you travel faster. So that means you have more anticipation before the analog goggle goes out of signal. But of course, I'll make a video just about digital versus analog in a more in-depth view, so you have a better sense of which one to choose. But in general, if you want to be future-proof, or you have a strong economic backbone, you should choose digital. In fact, this entire video series, I'll be using digital system because it's more future-proof. And I believe that in the next couple of years, analog will be eliminated completely from the FPV world. Now, I know at this point your mind is probably really confused about what every of those does, but that's okay, you don't need to memorize all of them. In a future video, we'll be going over how to assemble them step by step, starting from the next one. Now, keep in mind that this video right here is sponsored by T-Motor. Now, in case you haven't done your research yet, T-Motor is one of the best motor maker, as suggested by its name. They also make flight controllers, ESC, and plug-and-play FPV drones. Now, a great thanks to T-Motor for supporting us in building this drone in this video, so therefore we'll be using their parts. For example, we're going to be using T-Motor's motor, we'll be using T-Motor's ESC, and we'll be using T-Motor's flight controller, which I don't even know what I put it at this point. Now, as I mentioned earlier, your part may look completely different from mine. For example, your motor may look like this, your ESC may look like this, or that. There is just 1,000 different options on the market that you can buy right now. And that's a problem, because not every of them is made exactly the same. So, even though I said you can follow this tutorial no matter what components are you using, the truth is, to maximize your chance of successfully building an FPV quad, I still highly recommend you buying these parts, which I'm using. So in case you haven't bought your part yet, check the link in the description, because I put a list of what you need all down there. And make sure you buy those parts at fpvcreator.com if you can, because buying it there will not only help supporting us, but also guarantee you the highest customer service as possible, provided straight from us. And at last, if you find this video helpful, please consider leave a like and subscribe to our channel. This way, you'll be stay tuned to our newer videos, which we'll actually begin building on it. So, without much further ado, thank you so much for watching, and head on to the next video. And good luck in your builds.